Okay, I want to give you a couple of examples of how to apply basic trigonometric ratios. We have a situation here. There's a person standing with a string in his hand and is flying a kite. Kite is up in the air, and the string length is 25 meters. And if you consider the vertical line from the kite up to the ground level, the person is standing at a distance of 8 meters from that foot of the perpendicular that is dropped from the kite. So we want to know the measure of angle theta, which is the angle of elevation of the kite in the air. This letter theta is one of the letters from Greek alphabet, and it's used to represent angles in trigonometry. So we want to find the measure of angle theta, and as I said, it's called angle of elevation. We have angle of elevation, which is the angle between the horizontal line and the line of sight above the horizontal line. So there is this string which connects the person's hand to the kite, and that's the angle with which you are actually looking at the kite. And this angle is above the horizontal line. So the angle above the horizontal line between the line of sight and the horizontal line is called the angle of elevation. Now, there are situations where we have an object lower than the horizontal line. In that case, if you have, for example, the horizontal line and the line of sight below the horizontal line, that angle is called angle of depression. But the angle of elevation is the angle between the horizontal line and the line of sight above the horizontal line. For example, if you're looking at an airplane that is flying in the air, the angle with which you're looking at the airplane in the sky is angle of elevation, but the person who is inside the airplane and is looking at the cars on the highways on the ground, well, that angle between the horizontal line and the line of sight below the horizontal line is called angle of depression. So in different board problems, sometimes these terminologies are used and you have to know their meanings in order to be able to draw the diagrams. So this angle here is angle of elevation, sometimes known as angle of inclination as well. This is the diagram of the story of the problem, but this is a geometric diagram. We always draw a geometric diagram and we label it like A, B, C. We put the dimensions and everything, and then we use that to solve the problem. In this exercise, we know that the adjacent side is given as 8 meters and the hypotenuse is also given. So thinking of SOHCAHTOA, we're going to start thinking which one of the three trigonometric ratios should we use, considering the fact that adjacent side and hypotenuse are involved in this problem. If somebody says sine, well, that would be incorrect because sine ratio is the ratio of opposite over hypotenuse, and the opposite side here is not given and it's not even required. Even tangent would be an incorrect choice because it involves the opposite side. So the best option here is to use cosine of angle A or cosine of theta, because cosine is the ratio of adjacent over hypotenuse, and both of them are given in this problem. So we have to use a bit of logic and common sense here in order to decide which one of the three trigonometric ratios must be used in a particular problem. So we're going to go cosine of A equals the ratio of adjacent side AC over hypotenuse AB, and that will be 8 over 25. And then in order to find angle A, we are taking the inverse cosine of this fraction, and whatever answer we got, that will be the answer. I think I have a calculator here. So if I press the shift button or the inverse key and then the cosine button, inverse cosine of 8 over 25, it gives me 71.33. So 71.33 degrees, but we normally round to the nearest degree. So 71 degrees is the measure of angle A. So angle theta or angle A approximately equals 71 degrees. And that is the angle of elevation of the kite. Because it's a word problem, it's needless to say that always in word problems we have to write a final closing statement. In this other exercise, we have a building here, you have a ladder, we don't know the length of the ladder, but we know that the ladder makes an angle of 75 degrees with the ground. So what we're going to do, we are going to find the length of the ladder, given the angle 75 degrees that the ladder makes with the horizontal, and given the height that the ladder reaches on the wall of the building. So here the opposite side is given, the hypotenuse is required. So we're going to use sine ratio, logically speaking. So I'm going to say sine of 75 degree equals opposite, which is 2.8, over hypotenuse, which is L, and by cross multiplying, L times sine of 75 equals 2.8, and by dividing both sides by sine of 75 degree, which is nothing but a decimal number, we find 2.8 over sine of 75 degrees. So all we need to do is to use a calculator and divide 2.8 by sine of 75 degree angle, and whatever answer we get, 2.9 on the calculator, that will be the measure of L, or the length of the ladder. So we are going to write the length of the ladder is 2.9 meters. A final closing statement, or paraphrase in your own words to answer the word problem. Okay, and we used sine ratio because the opposite side was given, hypotenuse was required. Adjacent side was neither given nor required, therefore it was not logical. It didn't make sense if I would use cosine ratio in this exercise, or if I would use tangent that involves adjacent side. So I had to use sine ratio because it involves the opposite side and the hypotenuse. So we always have to think of what is given, what is required in a given problem, and then we have to pick and choose which ratio would be the best to pick to do that word problem or that question. Yes. So I hope you found these examples helpful and you will be practicing and doing more and more exercises in future. Thank you.